So for FRQ4, the first free body diagram consists for M1. So M1 has multiple forces acting on it. First, we have the tension. Tension 1 that's pulling it this way. Tension 2 that's pulling it the other way. And then on top of that, we have FG. But since this is a bird's eye view, so FG will be looking like this. Let's say this is on top of the force. And then FN will be coming towards us. And that will be for M1. And then for M2, we could do a similar thing almost. So say M2. So we know that T2 is going to be pulling it this way towards the center. And then we have our FN like before. And then this will be our FG, be more specific, M2. And the previous one we could write as FN M1. And then for part C, the period T is equal to 2 pi r, which represents the circumference. And in this case, R2, because we're finding for block 2, over V. V on the outside, which is for V2, which is the 4 meters per second. So then we say T equals to 2 pi R2, which is 0.75, all over 4. And in this case, the answer is 1.18 seconds. For the next step, we're finding AR. And we know that AR will just be V squared over R1 in this scenario, because this is what we have for the inner block. So, and what we can do is substitute V1 right here with 2 pi R1 over T squared over R1. Then we expand this, so then we know that AR is equal to 4, this is pi squared, R1 squared over T squared, and then this is R1, and it's the denominator right here, so it'll be in the same position as T1 right here. And then what we could do is we could simplify this. This 2 reduces, the second part reduces, so then our AR is just 4 pi squared. We only have an R1 left right on the numerator, all over period squared. For F, what we do next is we're going to do ratio. So we already got our AC M1 right here, which is 4 pi squared R1 over period squared. But then we need to find A of C. For G, we're trying to find the ratio of FC of M1 over the FC of M2. And we know that FC of M1 is just going to be M1 times AC M1 or M2 times AC of M2, which is this is for FC of M2. What I can do next is factor M1 over M2 times AC of M1 over AC of M2. Now this is from the previous part, so then we know that this is just 0.533. Our M1 is 0.05 kilograms over 0.03 kilograms. And then when you simplify that, you should get 0.889 as our ratio. For H, we're trying to find T1. So I'm going to take the net force of M1x, which is going to be equal to T1 minus T2. And we know for our net force here, which is just going to be FC of M1, which is going to be equal to T1 minus this T2 here is just going to be the centripetal force of M2. So FC of M2. Next, I'm going to move it to the other side. So FC of M1 plus FC of M2 is is equal to T1. Then I start expanding these ones. So we have FC of M1, which is just M1 V1 squared over R1. FC of M2 is just M2 V2 squared over R2, which is T equal to T1. So our M1 was 0.05 kilograms. Our V1 was 2.133 squared over R1, which is 0.4. Then our M2's mass was 0.03 kilograms times the tangential speed of 4 meters per second, all over 0.75, which is going to be equal to T1. And when we do that, our answer should come out to 1.21 newtons will be our T1 in this scenario. And then for 4i, it asks for the tension T2. And so I write out the net force of X of M2, which in this case is just T2. Our net force here is just our FC of M2, which is our T2. And because we found it earlier right here, T2 will just be equal to 0.03 times 4 squared over 0.75. In this case, that is just equal to 0.64 newtons. And then finally, for 4i, my bad, 4j, we're trying to find the net force. So in this scenario, net force on M1 is just going to be net force of Fx on M1, Fx on M1, because then it's the net force of Fy on M1 is just going to be 0. So then that means our net force at M1 will just be equal to net force M1x. And what we found earlier was net force of M1 of x is equal to T1 minus T2. And we know that T1 is 1.21 newtons minus our 0.64 newtons. And that comes out to 0.577 newtons on net force of M1. For 4K, we know it asks for what will happen if the mass increases. So let's write out for T2 first. So T2 in this scenario is just what we stated earlier. It's just M2 times V2 squared over R2. And what happens here is M2, as it increases, this will increase because it's on the top. Because if it's on the top, on the numerator, any increase that happens to M2, this whole T2 will increase as a result. So that means that as the M2 increases, that means the T2 will increase. And then we can look at T1 as well. So T1, we declared earlier, is equal to M2 V2 squared over R2, which is we got from FC of M2 plus M1 V1 squared over R1, which is FC of M1. And this follows the same concept as this because this M1 is on the numerator. As M1 increases, the FC of M1 right here would also increase as well. And because this increases, that means, and it adds to this one right here, the FC of M2, therefore T1 will increase as both masses increase.